Okay, so recall from the first video, the introductory video, we were trying to solve this differential equation via separating the variables, but this was not separable. It's not a separable equation because we tried to isolate x and y on both sides and we just couldn't. So this is not separable. So then the question is, well, what next? What do I do next? And I'll go ahead and talk about this a bit, but I do want to just say this is a first order, right? Obviously, first order linear differential equation. It is linear because it has the form of theorem 1, right? Here's my dy dx, right? There's a p of x in here, right, which is actually -1. It's a nice constant. And then my q of x, right, is right here. This is a function of x, which I will write in detail in just a bit. Okay, so it's not separable, right? This is going to be in your test. If it's not separable, well, what do? Okay, well, you try something else, which in section 1.5, we're basically going to follow these steps. First, you're going to determine if it's linear, and some will be linear and some won't. When it's linear, you're going to calculate what's called an integrating factor. And my integrating factor is going to be rho of x. It's like a little curly p, but we call it rho, so it's a function of x, which is e raised to the integral, and this is a p, this is my p of x. This is not a rho, this is capital P in our theorem 1p. Then we're going to multiply both sides of our integrating factor by rho of x. And we do that because we get a very nice form. We're actually going to be, we're going to recognize that on the left-hand side of the equation, which is going to be this guy, it's actually going to be the derivative of a product. So you're going to be seeing the product rule a lot. And after that, then we basically, the goal is to find the solution to the differential equation. So we're differentiating with respect to x, so we need the inverse operation, which is the integral. So this is our general solution. And of course, to find a particular solution, we are definitely going to be given an initial condition. So this actually has an initial condition, and if I write that down, our initial condition, I think I wrote it in the very beginning in the first video, but if I didn't, that's fine. It's our initial condition, so it's going to start at 0, or actually this is just 0, -1. So that means a solution to the differential equation, right? There's a lot of, there's going to be a lot of solutions that we're going to sketch, but the particular one is going to go through 0, -1, which is a y-intercept, right? It's going to be right there. Okay, so I will do example 1 in the next, well, actually, we can do it right now. See, I'm at 3 minutes. So let's start. So, we really have, so solve the initial value problem. And the initial value problem is, I'm just rewriting this guy. So 11/8 e to the -x/3, or a third x. And it goes through 0, -1. Right, so here's my x naught and here's my y naught from theorem 1. So again, we're just following the steps here. So the first step is to find the integrating factor. So the integrating factor is denoted by rho of x, right? I'm just, looking at my step 1, and that's e to the integral, and let me just change the color so we won't get confused with rho and p. Okay, we'll use this purplish. So p of x dx. So let's calculate that. That's not too bad. Okay, well, what's our p? Well, we can even write, we could actually write this before, but I'll just go ahead and write it now. What's our p of x and q of x since our ODE is linear? Well, my p of x is, it looks like it's -1, right? It's right here. My p of x is always that function in front of y, so that's my p of x. And then my q of x is, I'll just leave it in white here. So this guy is my q of x. So 11/8 e to the negative 1/3 x. Okay, so again, our integrand, okay, this is called an integrand, right? And so my integrand is -1, which is a very easy integral. So we have, I'm continuing with rho of x equals e to the integral of -1 dx. And if we integrate this guy, this is very easy, right? E to the negative x. And we have, let's see, negative x. And you can add a constant of integration. Actually, it's not going to affect the result of actually, I mean, when we start multiplying both sides by the differential, by our rho of x. So it actually doesn't matter. You can read about it on page 48. I believe it's remark 2. So it's just good reading, but we're fine with e to the negative x. So that is our integrating factor, and the next step, according to our method here, is to multiply both sides of our integrating factor to our original differential equation. So I have, let's get a different color here. Let's do yellow. Okay, so e to the negative x, so e to the negative x, and I'm going to multiply that by dy dx minus y right to the left, and I'm going to multiply my integrating factor to the right hand side. So 11/8 e to the negative 1/3 of x. Okay, so now that the reason we do that, now that we've multiplied both sides of the ODE, we're going to recognize this pattern over and over. I mean, notice, our q of x, right, is just this guy. It's just sitting there. We haven't done anything to it. Our rho of x obviously is new because we just multiplied it by rho of x. But this dx, okay, this is the derivative with respect to x of rho of x times y of x. Okay, so what do we have here? And let me just, so if we multiply, just distributive property, right? If we multiply this function inside, we obtain, let me get my white here. I'll go ahead and write it as, so e to the negative x dy dx, let's see, minus e to the negative x times y equals 11/8. And this is very nice. We can definitely use some algebraic properties here, right? We know e to the, a times e to the b is e to the a plus b, right? Law of exponents. So this is really negative x minus x over 3. Okay, so now here's where you're gonna recognize the product rule. This guy is always going to be, and again, just to get used to the notation here, I'm looking at this guy right here. So I have capital D for derivative, dx, and then I have rho of x, and I have y of x. So I'm going to go ahead and write that in. So I have dx, and then I have rho of x, and actually my rho, let's actually write it in, my rho of x, which is yellow, so that's my rho of x, times y of x. And let's see, they use brackets. Let's use brackets to be consistent. It's not wrong if it's parentheses, but just to be consistent, let's write brackets. And here you should agree with this. If you take this is just a product rule with respect to x. If you take the derivative of the product of these two functions, right? Remember, let's actually go ahead and write in the right hand side, right? This is just over 1, right? This is, you're just really you're subtracting fractions here, right? This is, if you want to write right? That's really 3/3, right? So negative 3x minus x is really negative 4x over 3, right? So I just subtracted fractions. But here, remember that, let's see, maybe a different color, just to star this. Remember we had two functions in single variable calculus, and you took the derivative, right? You get fg plus fg, and right, the derivative of the first times the second plus fg prime. So this is what we have here. If you take the derivative, so if you take the derivative of e to the negative x, well, that's just e to the negative x times -1 times this function. Well, that's right here. And now if you take the derivative of y of x, well, that's just y prime, which is dy dx, times e to the negative x. So this is always going to be true when you use when you multiply both sides of the ODE by the integrating factor, which is a very powerful tool. So now that we have that, okay, just to, again, follow the steps since this is the first example. So we just finished 3. So, I mean, our next goal is to integrate. And let me go ahead and, okay, so here, okay, I'm just going to write it again. Make it look a little nicer. Y of x equals 11/8 e to the negative 4x over 3. Okay, so what's our goal? Our goal is, and again, this is step 4. We want the solution to the differential equation, and it's right here. Well, this is a function of x. This is good. This is a function of x. We're differentiating with respect to x. I want my y of x. I want to isolate it, so I'm going to integrate both sides. And let's do my integral, I don't know, maybe this purplish. So I'm going to integrate, and I'm going to integrate, but this is with respect specifically to dx, so don't forget the dx. All right, remember a while ago you guys learned that integrals were the Riemann sum, right? You guys approximated using triangles or rectangles or trapezoids if you use Simpson's rule. But right, these were really the lengths of the rectangles and the widths to get the little area. So that dx is really important. Without the dx, the integral doesn't really make sense. And what I want you to see is, let me get my white here, right? This is the integral and the derivative that is 1. So we are left with e to the negative x times y of x equals, I'm going to take out that constant because we can. Okay, so we're almost done. And actually I'm going to stop right here just because I'm at 13 minutes and I can't exceed 15, and I probably will exceed 15. So I'll continue it on the next video, which will be shorter because we're about 90% done. So I'll see you in the next video.